Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 10, Section 3, Part 3. And as promised, we're going to talk about solubility rules. So please write these down. So these are compounds that are soluble, that will dissolve in water. First rule, compounds with group 1 metals like lithium, sodium, potassium, rubidium, and cesium will be soluble. They will be aqueous. Number 2, compounds with ammonium will be aqueous. NH4. Number 3, compounds with, now we're looking at the anion, acetate, Ch10.3 will be soluble, they'll be aqueous. Compounds with nitrates will be aqueous. So, for example, lithium chloride is aqueous. Ammonium sulfide is aqueous. Sodium acetate is aqueous. Sodium nitrate is aqueous. Rule number 5. So compounds with sulfates are aqueous except if you have them combined with calcium, strontium, barium, radium, lead, or silver. So if you have sodium sulfate, it is aqueous. If you have calcium sulfate, it is not aqueous. It would be insoluble. It would be a precipitate, so we would call it a solid. We would mark it as S for its state of matter. And our 6th rule is compounds with chlorides, bromides, or iodides are aqueous except when you combine them with copper, lead, silver, or mercury. So for example, sodium chloride is aqueous, but copper chloride is not. It would be a precipitate. It would be solid. So let's move on to our insoluble rules. Which compounds are solids, are precipitates? So our insoluble compounds, the ones that form precipitates, these rules apply unless they're combined with a group 1 metal like sodium or lithium and so on, or ammonium. So compounds with carbonates are going to be solid, insoluble precipitates. So calcium carbonate is insoluble, but our exceptions are group 1 metals, so sodium carbonate is still soluble. Compounds with hydroxides are insoluble, except for ones connected with group 1 metals or ammonium or barium randomly. So barium hydroxide is soluble, sodium hydroxide is soluble, but most of them, like magnesium hydroxide, insoluble. Number 3, compounds with copper, lead, silver, or mercury when combined with chloride, bromide, or iodide are insoluble. So copper chloride is insoluble, it is a solid. But we know sodium chloride is soluble, dissolves in water. Compounds with sulfide are insoluble, they form precipitates. So like magnesium sulfide would be a precipitate. And finally, number 5. Compounds with phosphates are insoluble. So let's go with calcium phosphate. That would be insoluble. It would make a precipitate. It would form a solid. Okay, we're going to go over a solubility worksheet, and it looks like this. Determining states of matter. All right, so all chemical species have a phase or a state. They are either solid, liquid, or gas, or they are in solution, aqueous. There are rules to determine which state the species is in within the reaction. Okay, number 1, if it's an element, look at the periodic table and it will tell you. If you know it's in solution, then it's AQ. And then all ionic compounds, unless they are in solution, are solids. And we know all acids are aqueous, and all molecular oxides, so covalent compounds, so nonmetals, any nonmetal with oxygen is going to be a gas. Now, if there's any compound that doesn't fit these rules, I'll just give you what state of matter it is. So the tricky part is, if it's an ionic compound, is it solid or is it aqueous? So if there's water in the equation, you have to look up its solubility. If there's no water, like maybe in a synthesis or a decomposition reaction, then it's very likely that the ionic compounds are solid. But if there is water, or if any of the elements or compounds are aqueous, then you need to look at the solubility table for your ionic compounds. Now this is for ionic compounds. So we'll quickly go over how to use this right now. Alright, so if you have a group 1 metal like sodium, lithium, potassium, or if you have ammonium, or if you have hydrogen as the cation, then it's going to be aqueous, and it's not going to be the precipitate. If you have chlorate, nitrate, or perchlorate as the anion, like sodium chlorate, it's going to be aqueous. Now, if the anion is chloride, bromide, or iodide, most of them are going to be aqueous with some exceptions. Your silver, titanium, mercury, copper, and lead. So magnesium chloride, aqueous, silver chloride, solid. So Ch3COO is the same thing as C2H3O2, which you know as acetate. Most of them are aqueous except for these exceptions: silver, lead, mercury, copper, and titanium. And then sulfate, most of them are aqueous with these exceptions: calcium sulfate, strontium sulfate, barium sulfate, radium sulfate, lead sulfate, and silver sulfate are all solids or precipitates. So sulfides, now we're flipping it. Most of them are insoluble. Most of them are precipitates. Most of them are solid, except if you have a group 1 or a group 2 metal like lithium or calcium, or if you have ammonium. So similar situation for hydroxide. Most of them are insoluble. They are solids, except if you have a group 1 metal like sodium, if you have ammonium, or strontium, barium, or titanium. Then, if you have a phosphate, a sulfite, or a carbonate, most of them are solids, except if you have a group 1 metal or ammonium. So most carbonates are insoluble. For example, copper carbonate is insoluble, but sodium carbonate would be aqueous. Okay, now we get a chance to practice this. Considering this chemical reaction, which I'll write below, what are the products, the precipitate, and the states of matter? All right, so we have barium chloride and sodium sulfate. And then I want you to figure out what type of reaction would this be. Would it be synthesis, decomposition, single replacement, or double replacement? And given that, then what would be the products? So I want you to write this down with your products, step 1. Then I want you to balance it, step 2. Then I want you to look at your 4 compounds and figure out the states of matter of each of them. And then I want you to tell me which one is the precipitate. All right, so there was a bunch of steps. I'll give you some time to do that. Okay, and one last example for this video. Please write this down. Write a balanced chemical reaction for reacting aqueous silver nitrate with aqueous sodium chloride. So what I would like you to do is to take the words and write down your reactants. Go from word to formulas. That's step 1. Step 2, you'll need to figure out what are the products. So I guess before that, you'll have to figure out what type of reaction is this going to form. Synthesis, decomposition, single replacement, or double replacement. And then step 3, what are the reactants? Step 4, what states of matter are all 4 of those compounds in? And step 5, what is the precipitate? Okay, good job on doing that. And in our, we're going to have one more video on 10.3 where we talk about applications of these chemical reactions we learned about. I will see you then. Bye.